In this video, I'm going to explain how to bind cadmium. Cadmium is found in chocolate. It's probably in a lot of those grocery store chocolates. So it could be a good idea to get your cadmium, or to get the chocolate tested for cadmium. I don't know how much that would cost, but yeah. So basically, the first step is the bromelain cleaving CD44 and CD62L with proline intact. So proline is in a bone broth. Basically, bromelain, you can find that on a pineapple. It's a protease with the proline intact. It's without cutting at proline residues. This selective cleavage can modulate immune cell trafficking and potentially expose the domains that influence downstream transcription, which is basically in the DNA and the chromatin that allows the genes to be expressed. Step 2 is a vitamin D gene transcription activation as a result of the bromelain cleaving CD44 and CD62L. Because once that is done, this enhances the signaling to nuclear vitamin D receptors. Vitamin D receptors are zinc finger transcription factors, so they need zinc for proper DNA binding. So a good way to make sure you're getting zinc is to make sure to not take too much copper, because a high copper reduces zinc. Also, you need a good form of a vitamin C. I'd say like acerola. There's some forms of vitamin C to not take. So basically, the right form of vitamin C keeps zinc bioavailable, so that it actually activates zinc finger transcription factors for proper DNA binding within chromatin. The chromatin has to open for that to work, which is where sulforaphane comes in from Brussels sprouts, other vegetables. Step 3 is adequate copper relative to lower zinc, which actually opens chromatin. So copper acts as a cofactor for some chromatin-modifying enzymes, like lysyl oxidase, that can influence chromatin structure. Copper also, I think it also affects estrogen in a positive way, which with estrogen actually activates the magnesium transporter that is needed for magnesium to be transported, so that the vitamin D receptor can work, because magnesium activates the vitamin D receptor as well. So a slightly lower zinc environment may reduce the competition for metal binding sites and transcription factors, or inside the chromatin. So that actually allows the activation of vitamin D receptor and other zinc finger proteins. Step 4 is with papaya, cysteine thiols. Papaya actually activates MTF1, which is short for metal transcription factor. This is the main part that binds cadmium, which is a heavy metal that's toxic, because once MTF1 is activated, it binds toxic metals like cadmium, sequestering them and inducing metallothionein expression, which helps in detoxification and metal homeostasis. So basically, papaya cysteine thiols are actually redox modulators, and these thiols in papaya activates MTF1, which is a transcription factor that senses metal ions and oxidative stress. So MTF1 is a protein that senses and responds to metal ions like zinc and cadmium. When there's excess MTF1, it can actually sequester zinc, which alters zinc-dependent pathways in cells. That's why it's bad to have cadmium, because if zinc isn't working, that means that the chromatin won't be able to close. And if the chromatin can't close, that means that oncogenes will be able to work, because the genes and transcription factors that make oncogenes work will actually be working, which raises your risk of cancer. Because if zinc is closed, or if chromatin is closed with enough zinc, then those oncogenes won't be activated. But cadmium, excess cadmium can sequester zinc, which means that the chromatin will be open and the cancer oncogenes will be activated. So MTF1 binding free zinc also reduces the zinc that is available for immune cells. So that means that they're not going to be able to fight. Your immune system won't be able to fight off the cancer cells that are activated by oncogenes. So zinc is needed for proper cytotoxic T cell and NK cell activity. So less available zinc means immune cells can't effectively recognize or attack cancer cells, and that means that cancer can evade the immune system. Okay, now here's where curcumin or turmeric comes in. It can actually downregulate MTF1 activity. So by lowering MTF1, it reduces zinc sequestration, which restores zinc availability for immune cells, which means that your immune system will be able to attack cancer cells. If zinc is freed up because of turmeric, then that means that it can close the chromatin so that the oncogenes that are driving cancer can be disabled. Also, another good thing to bind cadmium is also macadamia nuts. The reason is because they're rich in monounsaturated fats, and adequate intake supports normal kilomicron formation in the intestine. Now, the kilomicrons are important for fat-soluble vitamins like A, D, E, and K to be able to get into gut circulation. So through kilomicrons, these fat-soluble vitamins, like vitamin D, are efficiently delivered to tissues. This means that vitamin D binds to its nuclear receptor, or VDR for short, which functions as a zinc finger transcription factor. The zinc fingers are structural motifs stabilized by zinc ions, or from zinc, that allows proteins to bind to DNA and regulate gene expression. But that's only possible if the zinc is not being sequestered by excess cadmium. Also, MTF1, or that's short for metal transcription factor 1, is another zinc finger transcription factor that responds to metal ions, including zinc and cadmium. So basically, that means that you need zinc to be able to activate metal transcription factor 1, so that it can bind cadmium. But that's only with enough zinc, adequate zinc for proper VDR function that helps MTF1 bind metals like cadmium and regulate metal detoxification genes such as metallothioneins. So basically, MTF1 can actually regulate metal detox genes within the chromatin where the DNA is located. MTF1 is a zinc finger transcription factor. So basically, that could mean that I suppose that high zinc, if the MTF1 is sequestering the zinc, that means that the chromatin is going to be opened. If the chromatin is opened, then yeah, that means that the oncogenes are going to be driving the cancer cells. That the chromatin opened, that the cancer cells are going to be able to proliferate. So basically, that's a short recap. I could add a lot of more things into this video, but it would just be a long video. So like, subscribe, and I'll see you in the next one.